In 4.4 day 2 we're going to talk mostly about transformations, and transformations in this example is just that. These are really the transformations from yesterday though, as we're going to focus on some new ones today in later examples. So what we have to do, and this is very much like a couple of your problems in the assignment, describe the graph and label the window. The description is going to be down here, period amplitude transformations for each one of them. So we're going to take a look at those. Period, if you remember from yesterday, is you take 2 pi and you divide it by whatever the number is in front of x in each of these cases. In this one, we've got 1/2 x, so it's 2 pi divided by 1/2, which means the period is going to be 4 pi. For this one, we've got pi in front of x, and so we're going to do 2 pi divided by pi. That makes the period actually just the number 2. Amplitude, we have 5 in front of the sign. That means amplitude is 5. We have 3 in front of the cosine. That means the amplitude is 3. Nothing more fancy than that. Now, transformations, as far as these go, we're going to be looking at mainly just vertical and horizontal stretch and shrink. So with the amplitude, for both of them, the amplitude is 3 and 5. Those are both going to be stretches. That's actually the second thing that we do though. Let's look at the horizontal stretch and shrink on the first one. This one turned out to be 4 pi, which means that it is larger than the normal period. That is twice as large. So we would say that this has a horizontal stretch by a factor of 2. Over here, it's getting smaller, and it's going down to 2. Now, if something gets smaller, it's a shrink. It'd be a horizontal shrink in this case. But as far as the factor goes, it's just basically going to be the whatever we're dividing by pi. It's not going to be pi, because if the factor was a number larger than 1, then we'd be talking about a stretch. So if it's related to pi but it's not pi, then it's going to be the fractions, be the reciprocal of that 1 over pi, as far as describing that factor. The other thing is, with the amplitude in each one of these, this 5 means that it's a vertical stretch by a factor of 5. And the 3 means that it's a vertical stretch by a factor of 3. So we've got those things taken care of. The only other thing that we need to do is to label this graph. Now the graph is, you're going to see this in some of your assignments as well, but some of your problems in your assignment. It's 4 pi for one full period. Remember that a period is starting at one point, taking it all the way through until it starts repeating. So this out here is going to be 4 pi. And conversely, on the other side, we go all the way out to this other one, and that's going to be negative 4 pi. So we can get some labels going here. Probably in the assignment, they'll want you to say, what is the x range? So negative 4 pi to 4 pi. And then up here, you'll notice that we've got an amplitude of 5, so this is essentially 5. This one's negative 5. That makes this 10. That makes this one negative 10. So we're just labeling the graph, and in the way that the book has it, it'll probably be something like this. It'll probably say negative 4 pi, comma 4 pi. This is essentially interval notation, so that's the x values, that's the domain, and then the range of this graph, negative 10 to 10. So you'll see it looking like that. That's what that means when you see it labeled that way in the book. All right, now for the period and amplitude of this one. Easiest thing to see is the fact that, okay, so the amplitude's 3, it goes up to 3. That must mean that this is 5 and that this is negative 5. So that one's not too bad. The fact that the period is 2, if we start here and end here, that would make this 2. And we go another one, that would make this 4. And just the same way, we can go back in the negative direction as well. And so here we've got negative 4 to 4 for the x's, negative 5 to 5 for the y's. And so that's enough to label those graphs.